Good morning, all of you. Good morning. Good morning. Hope you all are good, well, and sound. Okay. Hope you all are fine and doing fabulous. Uh, no, I'm not going to take any CP today. I will let you know. I'll let you know. I think I've given you the date of CP. Did I give? I'll not take any CP today, but I think I gave you the date. It's 26th, I think. I've given you. Let me check it. Let me check it. Yeah, 26th August. I told you. 26th August. 26th August. It was given. Not today. Today is 25th, no? Yeah, today is 25th. Not today. 26th August. Tomorrow. Tomorrow I told you that I'll take CP. It's tomorrow's date is given. So don't forget. Tomorrow, 26th August, you will have your CP. Good morning, all of you. Good morning. Good morning. No, your CP is on 26th. I told your CP is on 26th. I send you the message also. If you see your WhatsApp group, you will see it's already given. The date is given 26th. It's not 25th. 26th. Okay. So 26th will have our CP plus performance and okay. So good morning everybody. So we'll have today we'll have some numericals based on simple pendulum. You remember simple pendulum we discussed in our last live session. In our last live session, we discussed about simple pendulum and we saw about the whole kinetic energy and potential energy calculation of a simple pendulum. If I show you this pendulum again, you see, I made this pendulum for you. See this pendulum. Okay, this is called bob. Now, if you this, okay, so this is called mean position, extreme position, extreme position. Understood? This is extreme position, and this is called mean position. Okay, and I told you that in mean position, potential energy equal to zero, but kinetic energy is maximum. And at the extreme position, potential energy is maximum, but kinetic energy is zero. I told you if you remember. I hope you have not forgot this. Okay. I repeat, we discussed that at mean position, kinetic energy is full, maximum kinetic energy, but potential energy is zero. But at the extreme positions, potential energy is maximum, kinetic energy is zero. We discussed this? Fine. This is discussed in our last live session. Okay. If you have missed it, you must see that. Okay, this is very important. Now we'll do some numericals. And I told you before that these numericals are not there in your textbook, but very important for your exam. Okay, since we are discussing in the class. So these are very important and we need to solve this. Okay, fine. So let's start. I hope you all are ready with your physics copy. Okay, physics notebook. Come on, be ready with your pen also. Okay, right. First, numerical. We'll do numericals only today. Okay, we'll do numericals only today. Right. The velocity of the bob of a pendulum, the velocity of the bob of a pendulum at mean position at mean position is 2 meter per second. 2 meter per second. Okay, find find its kinetic energy. Find its kinetic energy at mean position. Find its kinetic energy at mean position if mass of that bob is if mass of that bob is mass of that bob is 200 gram. Okay, 200 gram. Solve it. Where is the sum? We know the formula. Kinetic energy. You wrote the question, all of you? Okay. Kinetic energy equal to half mv square. But here mass has to be changed into kg. Yes, mass is given 200 gram. So change it into kg. So solve it. I am also solving so that I can check yours. We have to find the kinetic energy at mean position. That is half mv square. So half mass is uh, 200 by 1000, because we have to divide by 1000. Why? So that we can convert it into kg, into v square. Velocity is 2 meter per second. So v square means 2 square. That is 2 into 2. Solve it, all of you. So what answer you have got? Just tell me your answer. All of you, what answer you have got? Just tell me your answer. You must convert into kg. Okay. Yes, Gaurav has given answer 0.4 and Khushi has also given 2 by 5 joule. Nikhil 0.4. Sonia is 2 by 5 joule. Yes, 2 by 5 joule is correct answer. 0.4 is also correct answer. 0.4 joule. But don't forget to write joule. Joule is the unit. See, this is the sum. Those who has not solved yet, solve it. Can you see this clearly? Can you see this calculation clearly? Just write. So solve it. Kinetic energy equal to half mv square. See, mass I have converted into kg. 200 by 1000. Okay. So mass is 200 by 1000 into 2 into 2. Velocity square. See the way I have calculated? Okay, fine. Solve it, all of you. 0 0.4 joule. I hope you have solved it. Okay. Now, if you remember in our last live session, all of you listen me very carefully. Very carefully. Now things are going to be little complicated. Understood? We'll discuss something complicated now. If you remember in our last live class, I told you that total kinet total kinetic energy at mean position equal to total potential energy at extreme position. You must remember. Okay. Kinetic energy at mean position equal to potential energy at extreme position. Because in mean position, only kinetic is there, potential is not there. Okay. In mean position, only kinetic is there, potential is not there. But in extreme position, only potential is there, kinetic is not there. Understood? So that means what is the kinetic energy at mean position? That is the potential energy at extreme position. Understood? So kinetic, potential, they are equal. They are equal. Understood? Write the next numerical. Write down the next numerical. The velocity of the bob, the velocity of the bob the velocity of the bob of mass 400 gram, the velocity of the bob of mass 400 gram is moving with velocity, is moving with velocity 3 meter per second at its mean position. 3 meter per second at its mean position. At its mean position. Okay. The velocity of the bob of mass 400 gram is moving with velocity 300 meter per second at its mean position. Full stop. What is the potential energy? What is the potential energy at its extreme position? What is the potential energy at its extreme position? Can you solve it? Try it. Try it once. After that, I'll say you. All of you solve it and tell me the answer. Come on, try, and tell me the answer. It's nothing new for you. Whatever we discussed from that. I'm also solving so that I can check yours. Khushi has written 4 times her answer. I don't know why. Khushi again 5 times. I don't know why. Only one time is enough. I can see everything. Only one time is enough. You write just one time. Okay. So come on, come on. What is the answer? Khushi has written 9 by 5. Somanko has written 1.8. Somanko, just write once time. Why you are writing 3-4 times? 1.8 joule. Somanko has written. Khushi has written 1. This. Mangalam has written 1.8. Okay, okay, 1.8. Okay. Yes, 1.8 is the correct answer. 1.8 is the correct answer. But I do not know how you have done. All of you, start this sum in the way. I hope you have solved this sum, but start it in that way. Right. Your answer should be in this way. Right. Potential energy at extreme. Potential energy at extreme. 9 by 5 is also correct. 1 by 1.8 is also correct. Understood? 9.5, those who are getting 9 by 5 joule and those who are getting 1.8 joule, both the answers are correct. Full marks. But right, your answer should be as the way I'm saying you now. Potential energy at extreme position, potential energy at extreme position equal to kinetic energy at mean position. Okay, potential energy at extreme position equal to kinetic energy at mean position, equal to, again give, equal to, then you do half mv square. This way, this way, this way you do. This one, 1.8 joule. So I hope all of you have written this statement that potential energy at extreme equal to kinetic energy at mean position equal to half mv square. This is the correct way of solving the sum. Okay, if you are not solving in this way, marks will be deducted. If you just write half mv square and calculate, marks will be deducted. This is the way you have to do. Fine. Now next sum. Okay, now one question. Can you answer this question? When or where the bob covers maximum height, where the bob covers maximum height, at which position? Can you answer me? At which position bob covers the maximum height? Yes, Somanko has written extreme position. And other students, what do you say? First answer I have got, Somanko has written extreme position. Then Khushi Agarwal extreme. Okay. Where we get the maximum height, where it covers maximum. Khushi Agarwal. Okay. Another answer I have also got. Yes, correct. So at extreme position, Mangalam has also written, Bob covers maximum height in extreme position. Yes, 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 extreme. Aratrika has also written extreme. Okay. So when the bob is at extreme position, then it covers the maximum height. Okay. So write next numerical. All of you write next numerical. Yes. So the bob covered the maximum height at the extreme position. Next numerical. A bob of mass, a bob of mass, a bob of mass 500 gram, a bob of mass 500 gram reached the reached the maximum height, reached the maximum height 4 meter, reached the maximum height 4 meter. Find its kinetic energy. This Pradyuman Lama is writing Pradyuman Lama. I don't know why he has written his name, because just he has come after 25 minutes of starting the class. The class has started 25 minutes before. Now suddenly Pradyuman has come and writing his name. Means he is late. 25 minutes late. Okay. So next question is, what the next question I said? I forgot because of this Pradyuman Lama. A bob of mass 500 gram. Okay. A bob of mass 500 gram is covered a height. It covered the maximum height. Yes, I'm saying the question again. A bob of mass 500 gram reached the maximum height 4 meter. Reached the maximum height 4 meter. Find the find the kinetic energy at its mean position. Find the kinetic energy at mean position. All of you solve it and tell me the answer. Okay. If I repeat the question again, a bob of mass 500 gram is reached the maximum height 4 meter. What is the kinetic energy at its mean position? Solve it and tell me the answer. Yeah, gravity. All of you, if you require gravity here, then gravity you take 10 meter per second square. Okay. Wherever you require gravity, take 10 meter per second square. Can you answer me? Write the answer. Khushi Agarwal and Anand Mangalam. How did you get this 200 joule? I do not know. Khushi Agarwal and Mangalam. How did you get 200 joule? Come on, write the correct answer. I can see some students are writing 200, some are writing 20. 20 joule is the correct answer, not 200 joule. 20 joule is the correct answer. Okay. Yes, answer is 20 joule. I've calculated. But how will you start the solution of this sum? Write it. All of you write down how you should start the solution of this sum to get the full marks. Write it. The kinetic energy at mean position, kinetic energy at mean position equal to potential energy at extreme position. This line you have to write. I repeat, kinetic energy at mean position equal to potential energy at extreme position equal to, again give, equal to, and solve this one. Potential energy formula we know mgh. mgh. M is 500 by 1000. I'm converting into kg. G is 10. The value of gravity mgh. H is 4. So solve it, you will get 20 joule. Okay, done. Fine. So what I said, the kinetic energy at mean position equal to potential energy at extreme position. So we have to write this line whenever this type of sums will come. Okay. So this is the main formula actually. Kinetic energy at mean position equal to potential energy at extreme position. Okay. This is the way. Now next sum. Now next sum, all of you. Next question. A bob of mass, a bob of mass 100 gram, a bob of mass 100 gram is moving with a velocity 2 meter per second. A bob of mass 100 gram is moving with a velocity 2 meter per second at its mean position. Full stop. Is it possible? Is it possible for the same bob? Is it possible for the same bob to cover the maximum height? To cover the maximum height of 4 meter. To cover the maximum height of 4 meter. Okay, I told you 100 gram is the mass of the bob, right? Is moving with a velocity 2 meter per second. No, the mass is 100 gram and the velocity is 2 meter per second. Okay, is it possible for the same bob to cover the maximum height 4 meter? Answer it. You think on it. So is it possible for that bob Is it possible for that bob to cover the maximum height 4 meter? Answer me. The mass of the bob is 100 gram and it is moving with a velocity 2 meter per second at its mean position. Mean position. Now, is it possible for the same bob to cover a maximum height of 4 meter? Just think on it and tell me the answer. Is it possible for the bob to cover a height of 4 meter or not? Just answer it. What is the answer? Writing no sir, no sir, no sir, no sir, no sir, because potential energy at extreme not equal to kinetic energy at mean. Okay, cause mean position, so it will not be able to cover. Okay, at mean position height is 0, so it is not possible. No, 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 this is not the answer. Okay, let me help you. Let me help you. I told you that, see, I told you that the kinetic energy at mean equal to potential energy at extreme. Okay, kinetic energy at mean position equal to potential energy at max at extreme position. So first we need to find out what is the kinetic energy at mean position. Then find out potential energy at extreme position. Understood? If they are equal, if they are equal, then what I said, it will cover the maximum height of 4 meter. Then it will be correct. Okay. So first you find out the kinetic energy at extreme position, then find out the potential energy at kinetic energy at mean position and potential energy at extreme position. If they are correct, then your the what I said, that is possible. So see, I've calculated. This is the potential energy at maximum, means extreme. Potential energy at extreme. This is kinetic energy at mean. Okay. This is potential energy at, yes, extreme. And this is kinetic energy at mean. Are they equal? This is 4 joule. This is 1 by 5 joule. No, they are not equal. So it's not possible. I asked you, is it possible? No, it's not possible because they are not same. So what Somanko has given me, that I can say it's correct. Potential energy at extreme. So first of all, you write in this way, potential energy at extreme position. You write in this way. Potential energy at extreme position, then calculate this. Then write here kinetic energy at mean position. Then calculate this. Solve it. Potential G at min, sorry, potential G at extreme, this, and kinetic energy at extreme, kinetic energy at min. Do this. Done. Done, all of you. Now write in the next line. You write, since since potential energy at extreme not equal to, give the not equal to symbol. You know not equal to symbol? This. Okay. Since the potential energy at extreme not equal to kinetic energy at min, kinetic energy at min. So, so it is not possible for that bob. So it is not possible for that bob to cover the maximum height, to cover the maximum height of 4 meter, to cover the maximum height of 4 meter. Okay, this is the solution. Understood, all of you? Okay, I hope you understood this sum. Now next sum, all of you, next sum. A bob of mass, all of you, next sum, write down the next numerical. A bob of mass 200 gram, a bob of mass 200 gram is moving with a velocity, it's moving with a velocity 3 meter per second, 3 meter per second at its mean position, 3 meter per second at its mean position. Find the maximum height, find the maximum height covered by that object. Okay, find the maximum height covered by that object. Understood? Find the maximum height covered by the object. Solve it and tell me the answer. Find the maximum height covered by that object. Okay, solve it and tell me the answer. The object was moving with a velocity 3 meter per second. Mass is 200 gram. Okay. Find the maximum height. Okay, Anand Mangalam is saying, sir, repeat the question. Okay, I'm repeating the question. A bob of mass 200 gram is moving with velocity 3 meter per second. 3 meter per second at its mean position. Find the maximum height covered by that object. Find the maximum height covered by that object. So, what is the height? What is the maximum height covered by that object? What is the answer? What is the answer? Tell me the answer. First. Tell me the answer. Somanko has written 1.8 joule. I don't know what he has written. Mhm. And the value of G is required. If the value of gravity is required, take 10. Okay. And what velocity I gave? 3, no? The velocity I gave 3. What is the correct answer? Correct answer is, okay, we'll solve it first. After that, I'll tell you the correct answer. Not now. Write the solution. The way we need to solve it. Write it. Right. Potential energy at extreme position. Write down this. Potential energy at extreme position equal to kinetic energy at mean position. You have to write this line fast. Okay. I repeat, potential energy at extreme position equal to kinetic energy at mean position. This line you have to write fast. And written the next line. This should be the next line. Say, next line is mgh equal to half mv square. Here m we can cancel. See, mass are cancelled. You do not have to put the value of mass. The value of mass is given in the question, but we do not require it because we can cancel mass. See, easily I can cancel mass. So gh equal to half v square. G means gravity 10h equal to half v square, 3 into 3. Can you see this solution clearly? Is it clear on your device? Is it clear? So in this way, I have got height equal to 0.45 meter. In this way, we are getting 0.45 meter. Try to understand, all of you. So here we do not require to place the value of mass. Okay. The value of mass is not required only because we can cancel it from the first line. We can cancel from the first line. So easily we can solve h equal to 0.45 meter. And this is the way you should solve this sum. No other way. No other way. This is the only way we should solve this sum. no other way. Understood? You solved? Yeah, yeah. You are asking that if you place the value of mass, yes, yes. If you place the value of mass, answer will come same. Okay. I we have solved this sum. So here you saw that I have cancelled mass from both the side. Easily we can cut. So why to go for the longer calculation? But if you are placing the value of mass, that's not wrong at all. That's not that's not wrong at all, provided you get the correct answer. Okay. So this is the solution I have got. One more sum will do. Now one more sum. All of you write this. One more sum. The maximum height covered by the maximum height the maximum height covered by the bob of a pendulum. The maximum height covered by the bob of a pendulum is 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 4 meter. The maximum height covered by the bob of a pendulum is 4 meter. Okay. What is its velocity? What is its velocity at mean position? Okay. What is its velocity at mean position? Solve it and tell me the answer. The maximum height covered by the bob of a pendulum is 4 meter. No, 4 meter. What is the maximum velocity? What is the answer? Mass is not given in the question. Mass is not given in the question. So solve it in this way. Find the velocity. Mass is not given. Mass is not given. Don't ask me the mass. Mass is not given in the question. Without mass only, you have to find the value of velocity. You have to find the velocity without mass. Mass is not given. Are saying that, sir, I can't solve. No, no, you can solve easily. Easily you can solve. Easily you can solve. That's not a problem. Easily you can solve. Try, just try. Just try. At least let me get one answer. I'm not getting any answer. I'm not getting any answer. Nobody is able to solve it. Easy sum. Should I help you? Okay, let me wait for another 1 minute. After that, I will show you the solution. First, let me see who can give me the answer. Let me see. I'm sure that I'll get an answer. Nobody? Okay. Okay. So start solving this sum. All of you, start writing what I'm saying. Right. Kinetic energy at mean position. Write this. Kinetic energy at mean position equal to potential energy at extreme position. Understood? This line we have to write first. Kinetic energy at mean position equal to potential energy at extreme position. Written. After that, in next line, we'll write this. Say this solution. Say this solution. And from here, I'm cancelling mass. Mass are cancelled. See, like this, mass cancelled. Yeah, also I'm cancelling mass. So that's why I have not given you mass. That's why I have not given you mass. Okay, because mass is not required only. Mass is not required in this sum. That's why mass are cancelled. So half v square equal to gh. So in this way, put the values. Okay, put the values. Then get v. Okay. In this way, you can solve this sum. Try to understand, all of you. So mass is cancelled like the previous sum. In previous sum also we cancelled mass. So the same way I'm cancelling and I got the velocity v. Okay. So this is the way we have calculated it. Okay. Is not it easy? Yes. So you are asking about mass. Actually, mass is not required here. So if I give the mass in the question or I'm not giving the mass in the question, the things are same. It's similar. So that's the thing. So we got these sums. Now, as I told you before, these sums are not there in your textbook, but these sums are very important for your upcoming test or upcoming exams. Okay, so these are important. Don't forget all this. You must practice this. And one more thing, as I told you, I given you the date that tomorrow is your CP1. Yes, CP1 physics tomorrow, 10 marks. So don't forget, be prepared. Work, power, and energy. Whatever the numericals we have done, what are the numericals we have done in this live session? Not only this live session, means all the live session of this chapter, work, power, energy, all the live session, these numericals are important for your CP. Okay, for your CP, all the numericals which we discussed in the live session are important. Okay, so this much for the day. We'll bind up this class now, but before that, you must write your name in the comment and then you can leave the class. Okay, so first uh, you write your name and then you leave. Okay, thank you. Come on, start writing, all of you. Start writing. Okay. Come on, start. Well, if you start, write your name. Only one time is enough. Write only one time. That's enough. Okay. Write only one time. That's enough. Yes. So after writing your name, you can leave the class. Okay. Okay. So this much for the day. Let us bind up this class. See you in the next live class. Okay. Thank you all. Thank you.